Alright, so in this lesson we're going to start talking about power and what power really means and how we actually define power. So power is just a measure of the rate at which force does work on an object, or the rate at which energy is being used by a system. The rate at which the energy of a system is changing is really one way to think of power. By definition, the average power acting in the system is equal to the work done on the system divided by the time it took for that work to be accomplished. So if we kind of look at something like the pushing a block up a ramp versus lifting it straight up, the reason why you feel like it's less work to push the block straight up the ramp rather than lifting it straight up is that you're actually exerting less power pushing it up the ramp. The work done is the same. The time it takes for it to do is different depending on whether you're pushing it up the ramp or lifting it straight up. So look at instantaneous power now. So if average power is equal to work divided by time, we want to find a way to get instantaneous power out of that. So work we can define as force times displacement times cosine of theta. So let's plug that in. Force times displacement times cosine of theta divided by delta t. Now let's make the assumption that force and theta stay the same. So this is something like pushing an object up a ramp. So if we rearrange this a little bit, we get force times displacement over change in time times cosine of theta. And so what you end up with is really force times velocity times cosine of theta. And that'd be instantaneous force, instantaneous velocity. So if we want to define the instantaneous power, that's really the dot product of the force and the velocity is another way to work it out. So let's look at an example problem. Let's have an elevator car that's loaded up, and we're going to give it a load of 3,000 kilograms. It's going to be lifted up an elevator shaft 210 meters in 23 seconds at a constant speed. And I want to know at what average rate does the force from the cart do work on the cab. And so what I want to do first is I know the mass, I know the displacement, I know the time. I can say work times delta T is equal to power. I can find the work, force times S. Well, the force really is equal to the weight if we're at a constant speed. So mgs divided by delta T. And so what you find is that the power, the average rate at which the force does work, is 268,000 watts, or 268,000 joules per second. The unit of power is the watt, which is 1 joule per second. The last problem that I want to do is one that's a little bit, this one's a pretty straightforward one. I want to do one that's a little bit more complicated. And what I wanted to do is say we have a machine that's going to lift a 4 kilogram package from an initial position, and I give you the coordinates of the initial position, 0.5 I hat, 0.75 j hat, plus 0.2 k hat, to a final position 7.5 I hat, 12 j hat, 7.2 k hat in 12 seconds. And a constant force of 2 I hat plus 4 j hat plus 6 k hat newtons was applied to the machine by the machine to the package. And so I want to find the work done on the package by the machine and the average power of the machine's force on the package. So work is equal to the product, or the dot product of force and displacement. So we've got to find what displacement is. And so the displacement really would be x final minus x initial. And so let's subtract these two vectors. And so this would become 7.5 minus 0.5 I hat plus 12 minus 0.75 j hat plus 7.2 minus 0.2 k hat. And so there we go. We get 7 I hat plus 11.25 j hat plus 7 k hat. So there's the displacement. So the next step is I want to do a dot product. And remember what dot product is, if we do that calculation, is multiply the x components, multiply the y components, multiply the z components, and add those three products together. So 2 times 7 plus 4 times 11.25 plus 7 times 7, or 6 times 7, and we end up with 101 joules is the work done by the on the package by the machine. So if I wanted to find the average power, what I do is work done and divide it by time. 101 joules divided by 12 seconds, or 8.4 watts is the average power. So you can do some problems which look pretty nasty at first glance. Doing this dot product in general can be one way to make those problems a little bit easier. So it's kind of a quick overview of power and what power really means. We'll take a look at power in a little bit more detail when we start to look at some of the calculus and how we can use ways to calculate instantaneous power, other ways that we can get that equation.